Hello, Dan here from howtomechatronics.com. In this video, we will learn how to make a motorized camera slider with pan and tilt head. This project is 100% DIY, built with cheap materials like MDF and plywood and controlled using Arduino, 3 stepper motors, some buttons and a joystick attached on a custom designed PCB. Despite this, the end result is quite impressive, with super smooth camera moves enabling us to get professional looking cinematic shots. Using the controller, we can either manually move the camera around or we can set start and end points and the camera will automatically move from one to the other position. Also, using the supporting arm, we can mount the slider even on a smaller tripod at any angle we want and still get a stable movements. To begin with, I designed the slider using a 3D modeling software. You can find, download and get all dimensions from this 3D model on the website article. The link is in the description of this video. So I started with making the slider rails, for which I used 22mm thick copper pipe. I decided to make the slider 1 meter long, so I cut 2 pieces to 1 meter of length. Copper pipes can easily oxidize, so therefore we need to polish them with a metal polish. In my case, I didn't have one, so I used a toothpaste for that purpose. This wasn't the perfect solution, but still I could notice a difference and got the pipes a bit cleaner. Then I moved on with making the wooden base on which the 2 pipes will be attached, and also it will serve for mounting the slider onto a tripod. Using a circular saw, I cut 2 pieces of 21mm thick plywood and glued them together in order to get a single thicker piece. Then, using a solid wood, I made a replica of my tripod mounting plate and attached it to the plywood piece using a wood glue and a screw. Now the slider base can be easily mounted on a tripod. I will mount the slider rails to the base using 8mm threaded rods, so I made 2 holes in the wooden base and inserted the 138mm long rods, which I previously cut them to size. Next, I had to drill 8mm holes in the pipes, which can actually be a little tricky. For that purpose, I made a simple jig where I raised the pencil to a height of 11mm, or that's half of the pipe diameter. Then I secured the pipe on a flat surface and using the jig, marked the pipe from both sides. This enables us to get precisely aligned holes from both sides. So first I marked the drilling points with a sharp screw tip and then drilled them progressively using 2, 4, 6 and 8mm drill bit. After that, I inserted the rails through the threaded rods and using some washers and nuts, I secured them to the slider base. In similar way, using a piece of plywood and a threaded rod, I fixed the ends of the rails. Next is the sliding platform. Again, I used the circular saw for cutting the 8mm thick MDF boards to size according to the 3D model. I also made some 8mm holes for the threaded rods on which the bearing are going to be attached. For assembling the platform, I used a wood glue and some screws. Using a cordless drill, first I made pilot holes, then made the countersinks and screwed the 3mm screws in place. Once the panels were secured, I continued with installing the bearing system. The bearings that I am using are 608Z with outer diameter of 22mm. 2 washers and a nut between 2 bearings make enough distance between them, thus enabling good contact with the 22mm rails. In order to make the platform more secure, when using the slider at an angle in similar way, I inserted 2 more sets of bearings at the bottom side of the platform. At the end, the sliding platform turned out to work perfectly. Here we can notice that now, when moving the platform along the slider on my small, not heavy duty tripod, the tripod head cannot hold the weight of the platform, so I had to make a supporting arm in order to stabilize the slider. So using 2 pieces of wood and some nuts and bolts, I made a simple clamp which can be fastened to one of the tripod legs. The clamp has a bolt on which the supporting arm can be fastened. Next, I had to make a slot on the supporting arm in order to be able to position the slider at a different angle. I made the slot by simply drilling many 6mm holes close to each other, and then using a rasp I made fine straight lines. This supporting system ended up working perfectly. I continued this build with adding legs to the slider in case I don't want to use a tripod. I made them out of 8mm MDF. Using a handsaw and a rasp, I easily got the desired shape of the legs. Then, using some glue and 2 nuts, I secured them to the ends of the slider. The next stage is building the pan and tilt system, which will be attached on the top of the sliding platform. Using the circular saw, I cut all needed pieces with the dimensions taken from the 3D model. I used few pieces of plywood for making the hinge mechanism of the leveling platform for the camera when the slider is set at an angle, as well as some MDF boards on which I made appropriate holes for the motor and the bearings for the pan system. I moved on with installing the stepper motor and the timing belt for the sliding platform. On one side of the platform, I secured the stepper motor with a piece of MDF board and some screws and bolts, and on the other side of the slider, I secured an idler pulley, so now I can install the timing belt. Using 2 bolts and zip ties, I easily secured the timing belt to the sliding platform. With this step, the sliding mechanism was completely done. I continued with making the upper parts of the pan and tilt system. According to the 3D model, I made all appropriate holes for the stepper motor and the bearings and glued and screwed everything together. A friend of mine 3D printed 2 80-tooth pulleys for me. In this way, I got 5 times speed reduction relative to the 16-tooth pulley attached on the stepper motor. Now I needed to make a closed loop timing belt according to my setup, so I measured how much length of belt I needed, cut it to size and then simply glued it with CA glue and added a piece of tape on top of it. The CA glue does a great job with rubber, so the closed loop belt worked without a problem. Next, I started the final assembly of the pan and tilt system. First, I secured the tilt motor using some bolts and then added the 2 bearings in place while securing them in the slots with some epoxy. Then I secured the tilt platform onto the pan platform using some 8mm bolts, and at the same time I attached the 80-tooth pulley to it together with the timing belt. Here I noticed that the belt was a bit loose, but I added a small bearing in the place where the stepper motor bolts goes to act as a belt tensioner. This worked out, so now the belt had enough tension to work properly. Next, I secured the pan motor and added bearings to the top side of the leveling platform as well as on the bottom side. Then I inserted a bolt through them, added a truss bearing, the 80-tooth pulley and the timing belt, and on top of them I added the previously assembled tilt head. Finally, I secured it using a bolt, and that's it. With this step, the construction of the slider is completed. Okay, so next comes the fun part, or installing the electronics components. Here's the circuit diagram of this DIY camera slider project. So the 3 NEMA 17 stepper motors are controlled via the 3 A4988 stepper drivers. For controlling the slider movement, we use a potentiometer connected to an analog input of the Arduino, and for controlling the pan and tilt head, we use a joystick module which actually consists of 2 potentiometers, so it is connected to 2 analog inputs. There's also another potentiometer used for setting the speed of the automatic movement from the in and out positions. These in and out positions are set with the help of a push button. This push button has a pull-up resistor and it's connected to a digital pin of the Arduino board. There's also a reset push button, a power switch and a power jack, as well as the limit switch for the slider and 2 LEDs for indicating the in and out status. For powering this project, we can use voltages from 9 to 12 volts. Next, according to the circuit diagram, I designed a custom PCB in order to keep the electronics components organized. I did that using the EasyEDA free online circuit design software. The circuit had quite a few connections, so I used both the top and the bottom layer and managed to get functional and good looking PCB. Once finished with this step, I generated the Gerber file needed for manufacturing the PCB. Then I ordered the PCB from JLC PCB, which is actually the sponsor of this video. Here we can simply upload the Gerber file, and once uploaded, we can again review our PCB in the Gerber viewer. If everything is alright, then we can go on, select the properties that we want for our PCB, and then we can order our PCB at a reasonable price. Note that if it's your first order from JLC PCB, you can get up to 10 PCBs for only $2. Nevertheless, after several days, the PCBs have arrived. The quality of the PCBs is great, and I must admit that it's quite satisfying to have your own PCB design manufactured. Okay, so next I moved on with assembling the electronics components. I started by soldering pin headers to the PCB. This enables easier connecting and disconnecting of components when needed. I actually used pin headers for everything except for the capacitors and the resistors, which I soldered directly on the PCB. Therefore, I continued with soldering jumper wires to all electronics components. In this way, I can easily mount the components on the controller case and at the same time connect them to the PCB. As for the controller case, I decided to make it out of 4mm thick transparent acrylic because I wanted all electronics components to be visible. Again, I used the circular saw to cut the panels for the case to size. Then, using a drill and Forstner bits, I made the openings on the front panel for the buttons, the potentiometer, the power switch and the joystick. After that, using a 5 minutes epoxy, I assembled the case, and as for the front panel, I inserted and glued 2 bolts through which the front panel can be inserted and secured using some nuts on top of it. Finally, I started assembling the electronics by inserting the Arduino board and the 3 A4988 stepper drivers onto the PCB. Then I continued with inserting and securing the buttons and the other components on the front panel. Once I had them secured, I connected the components to the appropriate pin headers on the PCB. On the side panel of the case, I added the power jack and then inserted the PCB into the case. On the same side panel, there's also a hole through which I put jumper wires for connecting the drivers to the stepper motors, as well as for connecting the limit switch, which I placed it at the end of the slider. Using some heat shrink tubing, I organized the jumper wires coming out of the controller case, and finally, what was left to do is to connect the controller to the 3 stepper motors and the limit switch. As for powering the slider, I used 3 3.7 lithium-ion batteries connected in series producing around 11 volts. And that's it, the slider is done and it works perfectly. Now what's left in this video is to take a look at the Arduino code and explain how the program works. The program is based on the Excel stepper library by Mike McCauley. This is an incredible library which enables easy control of multiple stepper motors at the same time. So once we include this library and the multi-stepper library, which is part of it, we need to define all Arduino pins that are going to be used, define the instances for the steppers, as well as some variables needed for the program below. In the setup section, we need to set the initial speed values for the steppers, define some pin modes, as well as add the 3 steppers to the multi-stepper control instance called stepper control. Using the while loops, we move the slider to the initial position, or it moves until it presses the limit switch, and then it moves back 200 steps in order to release the limit switch. In the loop section, we start by checking whether the slider has reached the limit positions, or that's the limit switch, or 80 cm on the other side. With the next if statement, we increase the pan and tilt speeds with each push of the joystick switch. Then we check whether we have pushed the set button, which is used for setting the in and out positions. With the first push of the button, we store the in positions of all 3 stepper motors and also light up the in LED. In the same way, with the second push of the button, we store the out positions and light up the out LED. Then, with the next push of the button, we read the value of the speed potentiometer, which is used for setting the maximum speed of the motors. Also, we put the in positions into the go to position array, which is used in the move to function, which calculates the required speeds for all stepper motors separately. Then, using the run speed to position function, the slider automatically moves to the in position. In exactly the same way, in case number 3 or with another push of the button, we move the slider to the out position. In case we hold the button pushed for longer than half a second, the fourth case statement will be executed, which actually resets the in and out positions so we can set new ones. Next is the joystick pan and tilt control. The analog values we are getting from the joystick is from 0 to 1024, or when it rests in the middle, the value is around 500. So if we move the joystick to the left and the analog value is greater than 600, we will set the speed of the particular motor to positive. And opposite, if we move the joystick to the right, we will set the speed of the motor to negative, which means it will rotate the opposite way. In case the joystick stays in the middle, the speed is set to 0. This method is used for both axes of the joystick as well as the slider potentiometer. Actually, in the case of the slider potentiometer, we use its analog value to also increase the speed of the motor as we further turn the potentiometer. Lastly, we call the run speed functions for each of the 3 stepper motors, and that executes the above commands or rotates the motor appropriately. So that would be all for this video. I hope you enjoyed it and learned something new. Don't forget to subscribe, and for more tutorials and projects visit howtomechatronics.com.